Hey guys, we're on this first unit and it's just some vocabulary. That's really what we're looking at. So over here I have on the right, I have our notes open. This is from 1.1 where it just goes over some vocabulary. And then over here some self-check questions. So we're looking at shapes inscribed in circles. So that means this shape E, F, G, H is inside. That's what inscribed means. It's inside circle J. And we call it circle J because the center point is J. So it's asking which would be considered a radius of J. So a radius starts at the center and then the line continues out to the edge. So JG, this is actually a radius. See how it continues out to the edge of the circle. So that would be our answer. Let's just look at the other ones. G to I, see how that does not continue to the center? It's not a radius. Same with FI, that never goes to the center. And then E to G goes all the way across. That's called the diameter. And we're going to have a question that asks about that. So another vocabulary word is secant line. Which one is not a secant line of the circle D? So it's called circle D because D is the center. So F to M. So this is actually, if we go look over at our notes, look at AB right here. When it just hits the circle one time on the edge and then goes through on the outside, that's called a tangent line. So this is a tangent line. And a secant line is it crosses the circle at 2 points. So JN that doesn't go through the circle at 2 points. HF, that does not go through the circle at 2 points. And then FL does go through the circle at 2 points. So FL is a secant line. This is asking which one is not a secant line. So it would be the tangent line. These are just tiny line segments that we don't even label. Okay, so you would pick that it's not the tangent line. So JKLM inscribed circle P, we want to figure out which of the following would be considered a diameter. So remember, we're back to diameter. So that's the line that goes all the way through from one end to the other, but it must go through the center point. So it's JL. If I look at KM, that goes through 2 points. But this is actually called a chord because it does not go through the center. And same with JK and PM. PM's a radius, actually. JK would be a chord. It does not go through the center. Okay, given the following circles, which are similar? So all circles are similar because all that's changing is the radius. They're always 360 degrees. They always have the same shape, but that radius just makes it smaller or bigger. All right, so here we have a shape inscribed in circle J. We want to count the radii, so the radius. So remember, the radius comes from the center point out. So we just have to count. There's 1, I'm going back to the center and I'm finding every line. There's 2, center, 3, center, 4. So I would type in 4 on that one. And radii is just plural of radius. So there's 4 radii. This one is asking how many chords. So remember, a chord is, let's look. You can always recognize a secant line because it makes a chord of the circle. And here's an example. QR and ST are chords. So the diameter is actually a chord. It just goes from end to end. So I'm going to start with that. The diameter through the center, e.g., it goes from end to end of the circle, that's called a chord. So there's one. And then we're just looking from point to point. It hits the circle twice. That's 2. I can do that on both sides. 3. And then there's 2 other lines. See how I hit the circle twice. So that would be a secant line. Same thing right here with FG. That would be a secant line. And then there's one more. It goes through the circle twice from HF. So these lines are not chords because they only are on the edge of the circle at one point. These would be considered radii. So there's 6 chords in this circle. And that's it for this one. So if you need to go back and look, remember there's